Hello students, today's agenda is to check our homework. We're going to be completing the square, and the assignment for today is 10.12. Today students will be able to complete the square to be able to find x of a quadratic equation. Quadratic of a quadratic equation, including complex solutions. Okay, so let's start with one that is simple, and for this one I'm going to show you in a minute how to complete the square, but you can easily solve this one just by canceling. And so we subtract 4 from both sides, and so we have left x squared equals -4. We take the square root of both sides, and so x is equals to plus or minus. Remember, anytime you take the square root of something, it's plus or minus. This becomes my imaginary number, and the square root of 4 is 2. Remember that if the 2 in here in this case is a whole number, this coefficient, then we put it before or to the left of my imaginary number. Okay, so these are my two solutions. Again, that means that possibly my parabola, it means that my parabola will not touch the x-axis. So that's not by completing the square, this is by canceling. Now in here, we have already, and we saw a little bit of completing the square. I just want to make sure that we continue to practice it. But in here, we already have a complete square plus something else. And remember that this means, I want to show you really fast of what that means. It means that one of the sides is x plus 3. And so let's say that this is x plus 3. And then my other side is x plus 3. So if I had the whole polynomial, which it's going to relate and make more sense once we go to the next couple of examples, this will be x squared. This will be 3 times x is 3x. This will be 3 times x is 3x, and then 3 times 3 is 9. So basically, the area of the polynomial from this would be x squared plus 6x plus 9, and then added that, it will be then plus 12. Okay? You might say, what? Again, we're going to cancel this 3 here to start solving for x. And so we have now x plus 3 all to the second power equals -3. So this is going to be helping us once we solve by completing the square. Okay, so this is just kind of like a review. So x plus 3 is equals to, what I did was to take the square root of both sides so that I can cancel this square. And if I do it on one side, that's why I have to do it on the other. The square root immediately means plus minus. Negative inside of the square root means imaginary number. And then the square root of just 3 cannot be simplified. This is a prime number, so it stays in there. Notice how in here, because this is a square root, I leave it on the right of the imaginary number. If it simplifies to a whole number, it goes on the left of the imaginary number. If it's a square root, then it goes on the right of the imaginary number. Oops. Sorry about that. I just noticed that I haven't canceled completely. And so in here, excuse me, my x is equals to -3. Remember that when you have something with variables and something without variables, we cannot combine them. So you just write -3 plus minus imaginary number square root of 3. Okay, so this will be my two solutions. And again, anytime you have an imaginary number, it means that you are not going to touch the x-axis, but also it means that it came from a negative inside of the square root. And that's called a complex solution. Okay, some more examples, but now in here, we're going to be completing the square, or check if it's already complete. How can we check if a square is already complete? So let me show you really fast again with that little square. X squared, 6x. What I'm gonna do, the easiest way is just say x, right? So that will be your x times x is x squared. And then this 6x, since it's a square, it means that you have to have exactly the same measurement on both sides. So that means that, and we saw before that this is half. So I'm going to put the 3 in here and the other 3 in here. And that's how you get that 3 times x is 3x and 3 times x is, because this is the measurement similar to this, is 3x. And that's how you get your 6x. See, that's why we divide by 2. And then 3 times 3 is 9. So perfect. This is a perfect square. And when we have a perfect square, we can just say that it's going to be x plus 3, right? X plus 3 to the second power, because we have two sides. So that's my perfect square. And that's equals to negative 16, because that's what they told us. We take the square root of both sides. And so x plus 3 is equals to, remember, plus minus, the square root of 16 is 4, and the square root of negative 1 is imaginary number. We take away the 3 to cancel, and so x is equals to, remember, we cannot owe $3 and pay with imaginary money. So they're not like terms. We just bring down the negative 3 plus minus for imaginary number. Again, why cannot we combine the 3 and the 4, or the negative 3 with the 4? This is because it's like saying negative 3 plus 4x, right? This is just like any other variable. Okay, so we cannot combine terms that have no variables with terms that have variables. And again, that will be my two solutions. Complex solutions because it has the imaginary number. So they're called complex solutions. Now, what if I have x squared plus 6x plus 10 equals 0? Really fast with my, and I didn't use this model in class, so I hope it doesn't get you confused. Again, this will be x times x is x squared. Half of this, right, half of this will be plus 3, and we square it. So the 3 and the 3 will go here. That makes my 3 times x is 3x, and 3 times x is 3x. And this is the x squared. So in here, 3 times 3 will be 9. Oh, but I don't have 9. I have 10 in here. So what do I do with that 10? Well, I'm going to, and I might just eliminate this part right now so that it doesn't get confusing. I'm going to have to get rid of that 10 to both sides so that I can have it just like in the previous, have it on the other side and have my complete square on one side so that I can take or find the perfect square. Okay, I don't know if that made sense, but let's try it again. So I cancel this, and I'm going to have x squared plus 6x, and I'm going to add something to it so that I can complete that square. Okay, and you can tell what I'm missing. And on the other side, since I cancel the 10 to negative 10, it's going to be negative 10. But if I add something in here to complete my square, I'm going to have to add that in here as well. And so okay, again, the first step was to cancel the 10 because it's not a complete square. 3 times 3 is not 10, it's 9. So that's why you cancel it. But then once you rewrite that with the negative 10 on the other side, you have to leave a space so that you can complete that square. So how do I complete that square? Well, I'm going to have, if you don't want to look at this, you can just say, oh, I'm going to divide this by 2, and so it's going to be plus 3. I take this and raise it to the second power, and 3 to the second power is 9. And if I add it on one side, I'm going to have to add it on the other side. Okay? And so now I can say that this is this complete square. Now I have that 9 because I was missing it. I had only this section right here. Okay, I didn't have that part. And so that's why we had to go through these steps of completing the square. And so negative 10 plus 9 is negative 1. From this, you already know how to do it. So you take the square root of both sides. X plus 3 is equals to plus minus, and the square root of negative 1 is imaginary number. You don't have any other coefficients or the square root of anything. And finally, we subtract 3 from both sides, so x is equals to, again, we cannot combine because they are not like terms. And so it's negative 3 plus minus imaginary number. Okay, somebody asked me what if they put this 3 in the middle of the plus minus. I said, you're adding or subtracting imaginary number, not the 3. Okay, you're only subtracting 3, but that goes before the plus minus. And so those are my two complex solutions once again.